Kia ora Year 12 and Year 11 and some Year 10s. This is question 7 from the March 2020 AS Stats paper, done again and hopefully done better. So what I've done is I've redrawn the curve that was really awful looking at the end of the last video. And I want to just do some notes before we go through the question. So I think cumulative frequency curves are one of the worst done graph drawing bits of the AS paper, which is a shame because they're actually quite cool ways to represent data. So I've got some notes here for you that are also in the printed, the handwritten work solutions that are now up on Google Classroom. Things to watch out for when you're doing these. And some of them are really obvious, but you still miss them. Think about your scale before you start drawing. That was the mistake I made in the last video, right? So that meant that we got this pathetic little graph that was sort of filling up just that bit of the graph. We had all of this room here. So look before you start to draw. Use pencil first and then cover it up in pen, right? And make sure your labels are clear. On the y-axis, what you want to have here is the cumulative frequency. In other words, all of the fish in this case that are up to and including that length. Fill up the whole graph and don't draw a line, draw a curve. I reckon it's worth showing the end points to make your life easier. So to do that, we want to do a little bit of work with the raw data before we get drawing. And especially we want to think about those endpoints because it looks here like the fish are between 0 and 9, right? So if you just look at this without kind of doing some work before you draw, your endpoint is going to be at 9, but that would be wrong, right? And then the endpoint in the next one you might draw at 14. But what's going on here is that fish lengths are rounded to the nearest centimetre. So a fish that is 9 point, this would be a very short fish. I guess it would be a goldfish, right? So if you had a fish that was 9.48 centimetres long, it's going to be rounded down to 9 centimetres, and that means it's going to be counted in this category here. So when we go to draw the cumulative frequency curve, we have to take account of the fact that actually that 0 to 9 class is from 0 to 9.5. The 10 to 14 class is really from 9.5 centimetres up to 14.5, and so on, right? So I think a good way to do these is to have 3 columns. The first column with what you're given, the second column with the kind of continuity fixed up boundaries, and then I've put the midpoint here last. Now, I've put the midpoint in because in this question we had to find the variance, so we might as well do the midpoint work first. I'll get to that when I start looking at the video because that was what I missed out in the fast video that I did last night. Okay, so that's kind of the preparatory stuff, but you might want to take some of those notes down if you don't already have a good grip on how to do these curves. So going back to our case with the fish, this is what my diagram ended up looking like, right? And you can see that here I've just jotted down what these coordinates of the endpoints should be. So this is, my starting point is there were no fish that were shorter than 0 centimetres, obviously. Then there were 15 fish that were up to 9 in the group 0 to 9. In the next group, which was called the 10 to 14 group, there were some more fish. I forget how many fish there were. Let's see. Oh, yeah, back up here, right? So there were 48 fish between 10 and 14 centimetres, which we now know is really between 9.5 and 14.5. So we add those two numbers up together. So the 15 and the 48 get added together, and that gives me 63 up to 14.5. And then when I add in the next category of the 66 fish in this group, there were 129 that were up to 19.5. So the points that I'm putting on, this one here, where's my next one? The next one is at 14.5 and 63, so that was in there somewhere. And then 19, and actually we should mark these on with crosses, then 19.5 and 129. And 30.5 and 150. And try and make them accurate. Now, I actually have real trouble with the size of those squares, so hopefully you don't use a ruler to help you out, right? But I think if you've done this kind of work, hopefully the marker can see that if you're a tiny bit off, it shouldn't matter too much. The things that they're really looking for are, do you understand the kind of continuity fix-ups here? So that's what our cumulative frequency should look like. And then what we're going to do is we're going to use that graph to figure out roughly what the value of D is. So things to watch for in this question is that we're asked 40% of these fish have a length of D centimetres or more. So if you're doing this and you're in a hurry, you're going to go, oh, 40% of 150 is 60, right? But that's not what we're looking for. We're saying 40% of these fish have a length of D or more, so 60% have a length of D or lower. So what I'm looking for is the 90th fish, right? So 60% of my fish will give me the 90th fish. Where's the 90th fish? This is very easy if I've got a ruler. Where's my ruler? Right, so let's go up here. You can see 80 on here, and then you can see 90. I'm not going to make that. Am I going to make that bigger? Yeah, I can make that bigger. There we go. Okay, so up to the 90th fish. 1, 2, 3, 4, 5. I think that's 5. I really need to go and get some new glasses. Right, there's the 90th fish. We're going to rule back down, take the ruler, spin your ruler around, which for some reason I can't do. Okay, forget about the ruler. You just get your ruler out and have a look at that 90th fish. What have we got? Fish number 90 is sitting about, oh man. Okay, so you really do need to take a ruler to this exam. So that looks to me like fish number 90 is sitting at about 16 centimetres. Okay, but I might think that because I looked at the mark schedule. So 16 or 16.5 centimetres, but you get the idea, right? So this is the thing we use these graphs for, is we're going to pick a value here, and we're going to wash over to our curve, and then we're going to drop down and say, what is that number? And I get 16 centimetres. The mark schedule's got 16.5. Honestly, I think it's going to depend a tiny bit on how you draw your curve, but you should be pretty close to 16.5. So then the next part of the question is to figure out an estimate for the variance, which is a measure of the spread of the lengths of the fish. And we're given a formula for that in the formula sheet. And there are two versions of that formula sheet, but the one we want to use for computation is the standard deviation one, is what we get. And on the formula sheet, it's called grouped data. So the standard deviation is the square root of these, the sum of the x squared f's over the sum of the f's. I'll explain what all this means in a minute, minus this. Okay, so where does this come from? Well, where it comes from, and sorry, there was a tiny gap in the video there because the dog is making noises and I needed to go to the formula sheet and just check something. So this is what we're going to use to compute the variance, right? This is what we're given on the formula sheet. So this gives us the standard deviation. We just need to square that. So for the variance, we're going to get rid of that square root sign. But it's coming from here, which is a more meaningful way to look at this formula, right? So this is just to work it out, but it doesn't really tell us what's going on. What we're doing when we find the variance is we're taking the distance of each fish length, looking at how far that is away from the average. We're squaring that number to get a measure of the kind of, think of it as the squared spread, and then we're timesing it by how many fish are in that group, right? We're going to use the midpoint of each fish length because we don't have data on exactly where each fish is measuring. And then we're going to divide by the total number of fish. Right? We're not going to use this formula because it's mucky. So what we have to do here for the variance, and once you've done this once, this sounds hard when I'm doing it the first time, it's actually pretty easy. All we've got to do is we've got to go this, so what I have to have here, so I have to go back to my data and work out how many fish I've got in each group, right? But we're going to use the midpoints. So here's my 0 to 9 category, but the midpoint of that category we worked out before was 4.75, right? For the next one, the 10 to 14 group, which I'm going to put in inverted commas because it is really 9.5 to 14.5, we found that the midpoint was 12. For the 15 to 19 group, we had the midpoint was 17. And for the last group, we had that the midpoint was 25, right? Because the 20 to 30 group goes from 19.5 to 30.5. So we take these midpoints, and that's what I'm going to use for the x. So I'm going to assume that all of the fish in that group have got a 4.75 centimetre length, because that's the best thing that I can assume. And then we look at how many we've got in each of those groups. Well, we had 15 in that category, so that's my frequency number there. We had 48 fish in that category, 66 here and 21 here. So to do the variance calculation, what I have to do is to take the x number and square it and then times by the 15. And the total number of fish we had here added up to 150. So that's the sum of the frequencies, right? So in here, the variance is going to be 4.75 squared, right? So my x number squared times the 15 fish in that group, and so on. So we're going to get this plus 12 squared times 48 plus 17 squared times 66 plus 25 squared times 21. So that's the top line of that first term divided by 150 for the denominator, and then I need to subtract off the mean squared. Now, hopefully, lots of you should recognize that this is kind of similar to the big idea of the variance as being this. Right, so that's what the variance really comes back to. And the computational version of that is e of x squared minus e of x, the mean, all squared. So what we're doing when we do this with this formula is we're doing this for grouped data, but it's the same concept. And when you chug those numbers through, you should get a variance number here of 29.1. Okay, thanks for watching. I know that video was really slow, much slower than usual, but please make sure that you've got this skill down so that you can just smash this question out if you get one of them. It's the kind of problem where people will often get either full marks or really, really low marks. If you see any other examples of this where you're not sure, feel free to send me in an email and I'll do another video for you.